Thanks, Tom. I'm curious about a move that you made in somewhere in the middle.
Yeah.
So it was this sort of you started motivating things with this these passages from Howard's paper where he was developing an analogy between ether or ether theories and quantum mechanics. And at some point, it seemed as if you wanted to say, well, the reason that we shouldn't think that the projections in our lattice of projections are referring to whether or not some system has certain properties or attributes or something like that. That we shouldn't be thinking about assigning probabilities to the possession of properties. Was that we should give up on the idea that there is a notion of a quantum system that would be the possessor of these properties in the first place, in much the same way that we would go on to give up on the notion of the ether as the thing that carries the energy and momentum and so on that we associate with the electromagnetic field. But I think sort of two things puzzle me about the way in which you develop that idea. One is, I would have thought that in the electromagnetic case, what we ended up doing wasn't to say there is no electromagnetic field or something like that. What we said is there's no ether that's the possessor of these properties. Instead, there's a new kind of entity that can be characterized as just with regard to being the possessor of these properties, right? There's no further story that I can give. I would have thought you could do the same thing here and say, rather than saying, well, what we really need is some fuller account of, say, in the Bohmian sense or in the Everettian sense, say what a quantum system is the sort of thing that possesses properties in just the sense, in some cases indeterminate and so on, as described by the quantum formalism. But you didn't do that. Instead, you seem to embrace a kind of phenomenalism where these are, probabilities concerning the appearances that I wasn't sure I understood.
Yeah, well, I mean, one thing I would say is my second reason for rejecting the view, which I did say, did mention, I didn't lay out, is this idea that if you just take the formalism as given and you want to characterize the properties that you can expect a quantum system to possess, substantial property-bearing entity or not, it will possess them for, at most, a set of times with measure zero.
Yeah, but that seems like the kind of thing that we've learned about the world, perhaps. Like, that's what quantum systems turn out to be like. They don't possess properties in the way that we thought systems had to possess properties coming from classical physics.
Well, yeah, you could just bite that bullet. So for me, I think that's an indication that we started off on the wrong track. And then we need to go back and think about what the significance are of these time-indexed projections in the Heisenberg picture.
I want to make a suggestion here that if I've got a list of questions, I've got an ordering. If you have a question that's a specific comment on what's just being said, raise one finger. And then, okay, then I'm going to go by the order I have. You're next.
So you went through one thing that grabbed my attention right at the end very quickly. I wanted you to say a bit more about it. So you said that you were in some way, there was some role for operators that didn't emit self-adjoint extensions. And so I was just wondering, what that looked like, how you'd interpret them, and how, if you'd like to connect them to this stuff that Brian Roberts has been developing about imaginary operators and imaginary eigenvectors.
Yeah, so I mean, in Brian's sort of menagerie of strange operators that we might take to have physical significance, these symmetric operators without self-adjoint extensions are really very tame. So they lead to probability distributions in the same way as a self-adjoint operator would.
Unitarity sometimes fails.
Well, what one finds is that, so one of the nice things about self-adjoint operators is that they, well, the Stone's theorem tells us that they generate unitary symmetry groups, these one-parameter families of unitary operators. So a maximally symmetric operator, one that doesn't have a self-adjoint extension, can't do that. But what it does is generates a semigroup of these unitary transformations. So in the case of time observables that I sort of touched on, that's actually very handy because the restriction on the existence of self-adjoint time observables is that were there a self-adjoint time observable, the energy of the system would have to be unbounded from below, which is a strange condition for a physical system. But if you have a maximally symmetric time observable, it generates a semigroup, and that's just what you want because it doesn't force the energy of the system to go below some minimum energy level.
You're next.
Me?
Yeah.
Okay, so this I thought was a very interesting, illuminating paper, and I really like the probability first slogan you had. And I have two questions that are related to, well, one is, it seems to me there's a certain way by focusing on the experimental outcomes. In a way, what you were looking at was what the probabilities are defined over, rather than the probabilities themselves. And those turn out to be classical probabilities over Boolean subalgebras.
Yeah, so, I mean, and this is a point that Howard Stein makes quite well, that this talk of quantum logic is somehow misplaced because quantum discourse takes place in the context of classical logic.
Yeah.
And when we look at these...
No, I'm not yet arguing for quantum logic. But I'm just observing that the first thing you talk about is classical event spaces over which the probabilities are going to be defined.
Yes.
And then I think you should address, I would like you to address the fundamental thing about that drives people to go to the projections. Namely that the projections are going to be associated with different classical events relative to different Boolean subalgebras. But the probability is always going to be the same for that projection, no matter where you project it. And the quantum probability always gives the same probability to the same projection as realized in one or another Boolean subalgebra.
Mm-hmm.
And that's crucial for how Gleason's theorem is proved.
Yeah, and moreover...
That's the reason for saying, well, another point of view is that the probabilities are defined, for saying that that's what they're defined over, as it were. Because it's that space which constrains the probabilities the way Gleason's theorem does. And if you just break it up into the Boolean subalgebras and you ignore that deep connection, that somehow is missing. So
yeah, I mean, so what keeps me up at night, and this is an ongoing conversation I'm having with John Ehrman, is the role of projectors in Luder's role, which is provably the way that you update your conditional probabilities.
Right.
It's really the only way to do it in quantum mechanics.
But that's connected in a way because you can derive Luder's rule from Gleason's theorem.
Sure, yeah, that sounds right. Yeah, and projections turn out to be the only sort of positive operators that suffice to play that role. Namely, that if you condition on a positive operator, you want then the probability of the event represented by the positive operator to be 1. You've conditioned on it, and that's only the case if it's a projection. So yeah, that's the kind of thing that keeps me awake at night. And I could go into my my various plans to get around that, but perhaps that's going too far afield.
So actually, the line that Kareem quoted this morning, of quoting Howard, quoting Wigner, is one of my favorite lines about quantum mechanics. It doesn't. You don't just compute probabilities for scattering amplitudes. We also calculate the density of lead. Aluminum, I'm sorry. Yeah, whatever. Well, we do lead too. And so it's just running through the base, the standard calculation. If you just look at the standard arguments for how you actually calculate the density of lead or aluminum in quantum mechanics, It's difficult for me to get a grip on what the mathematics means on your picture. What are the events that are eventuating, that are being represented in this calculation?
Yeah, so I plan to touch on, this is obviously a cop-out, I plan to touch on the sort of worry in the second half of my talk, where I try and develop this analogy of Stein's in a bit more detail. But, so, ultimately, the line I think I would want to take along these lines is that what I'm after is a sort of minimal ontology, a minimal metaphysics with which we can interpret the quantum formalism we have. So I'm inclined to start off with a sort of Humean metaphysics, where all we have given are these particular matters of facts, the events of our world, the entire history of our world. There's no necessary connections between them, but somehow quantum mechanics tells us about the probabilities between them. So then there's a commitment that somehow all physical probabilities are going to be realized within that pattern of events. And maybe you need to tell some sort of best systems analysis story, so on and so forth. But that's, I think, the idea that you need to be committed to somehow a sort of substantial interpretation of the objects of science, of scientific laws, can be shown, at least in principle, to be avoidable by taking, say, human mosaics kind of picture. I mean, does that say anything to your worries?
I see where you're going. I'm not sympathetic to it, but it's not like it's wildly incoherent and wrong, manifestly. Just mostly.
Well, actually, Eric anticipated what I was going to say. Eric's going to make reference to the density of aluminum. So, on your picture, a block of aluminum, there's really, all there is, well, what we would think there's a large number of atoms, and what you're saying is, well, actually, every once in a while there's a little flash here and there, and then
not every once in a while.
Well, compared for each atom is only going to be subject to is going to be subject to very rare flashes. So
no, this is not GRW.
Okay, so you've got a flash rate that's very high.
Yeah, well, it's going to ultimately it's going to be calculated in terms of the quantum state. But let me just tell you the metaphysical picture.
So what? Because you introduced your flashes as GRW flashes. So tell me what these flashes are.
Well, can I tell you what an atom is instead?
Yes.
Sure. Yeah.
So an atom is a stable dynamical pattern. It's stable over very small time intervals for compared with our experiences, the sort of events that we can distinguish, which gives it the appearance of something solid. The gaps for the atom are not gaps for us at all. That's kind of the picture. It's a stable dynamical pattern in equilibrium with its surroundings.
So, are you going nucleus? So, a nucleus of aluminum. What's the atomic number? Anyway, so
it's the characters of the dynamical patterns.
right,
Realized
so
in, say,
there's
the
going to
human
be a
mosaic.
pattern. So, every nucleus of aluminum is going to be a pattern of flashes occurring rapidly on human time scales.
Sure, yeah.
Then
It's
these
like
flashes
these
aren't.
two tables.
Then these flashes aren't doing anything at all like what they do in GRW theory.
Right. Yeah. Maybe I shouldn't have even
Yeah.
mentioned that. I just like that, galaxy of events.
Okay.
So that was probably misleading.
Okay, but the real worry though. Sorry, that was very clarifying because I was confused what you were. The real worry though is that if you take our science seriously, a block of aluminum has associated with a certain mass density, and the nuclei has a certain charge densities and things like that, and, which we regard as properties of the space-time region. Now you can tell a human story where, well, if I do an experiment that I regard as weighing the thing, here's the probabilities for the outcomes of the things, but I shouldn't think that the mass of the aluminum is really a property of the aluminum. Yes, you can. That's not logically inconsistent. But my worry is that you're rather than looking at our physics and asking what our physics is telling us about the world, you're sort of shoehorning it into metaphysics. But that's what I say in general about a human approach to these things.
Yeah, I mean, personally, I take a human metaphysics to be kind of trying to do the opposite. So avoid as insofar as possible shoehorning any metaphysics in. But
I think it's exactly the opposite. You're trying to shape physical theories into a metaphysical mold that they don't willingly go into.
Well, for me, the motivation is experience, and this is why I actually find Stein to be such a sort of motivating influence, that I really care about, the nitty-gritty of how we represent what gets experienced in terms of quantum mechanics. So the idea is, for me, is that one should start with experience and then sort of build up an interpretation from there. So the metaphysics that is being shoehorned, in your view, is somehow coming from what we have to believe given the way that we experience the world, or at least that's the hope. And just an answer to your question about dynamical properties. So on the very simplest conception, the very simplest property that you might think I have a problem with is, say, velocity. What's the velocity of an event? Velocity of particles seems very well defined. Well, I think there's a simple thought experiment to see that it doesn't make, it's not necessarily a problem. So are you familiar with Conway's game of life? So there you have these successive configurations. In each configuration you have a grid. Each place in the grid is either on or off. Think of those as events. What you get in the game of life is all sorts of dynamically stable configurations, which are nothing but these dots. But it's very hard to say that these things don't have velocity. Velocities, they have something like a group velocity. And so that's the sort of intuition.
Yeah, that wasn't the concern.
Okay, well, we can talk about that later.
We have time for one short question, and you had your hand.
Yeah, I'm not sure how short it is. So it's just, I'd like to hear more about how you think mental representation comes in. So one way of thinking about how the story should go, we need persisting things governed by quasi-classical laws, where causal talk and the right kind of counterfactual relationships between the states of the persisting thing and the things they're observing hold. But when you had the quote from Bell, you had these sort of galaxy of events, and it looked a bit like kind of magical psychophysical parallelism of conscious experience events supervening on big clouds of micro events. But maybe you can kind of square the circle and underwrite the facts about the latter thing in some story which does involve sort of fairly standard functionalist philosophy of mind about when a representer is in a state of representing something.
So there's a problem of somehow representing the world in terms of what is not the case, if this is the ontology. I'm not seeing what's the connection with consciousness? Or sorry, the ability to represent causally the capacities of these objects.
So when you were giving the Conway's game of life example to say these things have velocity, I would have thought it's at that level that you have something like representatives. In Conway's game of life, the gliders persist, and if you can kind of imagine that you could have things at that level representing things also at that level, things in their immediate experience because the right kind of counterfactual relation is held between, if they're, if something happens like this in their environment, then they're going to be in that state. That's why that state counts as representing that thing, and it has to be stable, it has to be connected to actions and the rest of it. Now, unless you're telling a story like that, I just don't understand how you really have experiencing observers in the picture.
Okay, yeah, I think I see your worry. I probably share it in some sense, but I think there's the sort of hope that one might have is that you can, well, first, the sort of picture that a quantum world in these terms is going to give us is one without strict determinism, I think. Now, perhaps that's beside the point. Ultimately, this sort of correlation of experiences with external events, experiences being at one level, events inside the brain. We're agreed on that point.
Maybe.
Under some description, experiences events in the brain. No,
Yes,
I mean they're in.
but only in virtue of lots of external stuff.
So the worry is that whatever's going on in the brain is just completely determined. I think we're going to have to talk about this later because I'm not quite sure I see what's going on. Sorry.
Thank you very much. Thank you.